Good day, class. This is Elton speaking from South Africa. I'm from Cape Town, South Africa, and today I will share with you some of my points, two of my topics that I've learned over this course. Okay, number one, I want to speak about propagation. Propagation is the movement of sound through a medium. There's different mediums. There's the air, metal, water. Sound travels through these mediums at different speeds. Propagation is the manipulates the properties of sound, like temperature, humidity, and then also elevation. Elevation being sea level. We can say sound generally travels at 340 meters per second, 1 feet per 1 millisecond, 1 kilometer per 3 seconds, 1 mile per 5 seconds. It's not precise numbers, but because it varies on some factors, but it's useful, or it's good to know the numbers. Regarding the idea of space, if we look at space, space is the area wherein that how sound travels from one object to another, maybe from moving from a surface like a wall, reflecting back, or from out of my mouth to another person, the time it takes to reach there or back. So that is regarding space. So much also that will happen in a mix. In a mix, you will have your space, or you will have to create space, the depth, and also relocation, and all this is based on the idea of propagation. The second topic that I want to discuss is amplitude. Amplitude is the extent of which the air compresses and also rarefies as the wave moves through the air. There's many types of waves. One type that we will recognize is on a pond. The waves that does this perpendicular movement. It also moves in the direction of the propagation, but it's perpendicular. A good example of that is like a guitar on a guitar string. The movement that it does on a guitar string, and that we call a transverse wave. And then there's another wave that we get, which is in the air, that moves parallel with the propagation, which is called a longitudinal wave. Then the next point is amplitude is measured in decibels. In the air, there is or decibels, or in short, like they normally say, dB. The thing that needs to be remembered is the letter that follows after the dB. Number one, which is in the air, would be dB, SPL, which means decibels of sound pressure level. In this dB, SPL, there's no definite place where the zero can be, because it relies on different contexts where it can be put in. The second one we get is in the digital domain, which is the computer, where it's been measured in dBFS. decibels in full scale. That normally would be from the most quiet notes to more quiet to negative, be measured in the computer. Out in the air, where we get dB SPL, it will be measured from the most quiet notes to the most loudest note, where you reach that painful level. So that's the difference between the two. Although we talk about dB, we should know that what is the difference. SPL, which is in the air, FX, that's full scale, which is in the computer. Let's just recap. We've covered propagation. What is propagation? Is the way that sound moves through a medium which is air, metal, or water. And then also the speed that it moves through. As we said, there's a speed that we generally have is like 340 meters per second, 1 feet per a millisecond, 1 kilometer per 3 seconds, 1 mile per 5 seconds. So it's not exact, but because there's a few reliable factors that can be accounted for. So, but it's also always good to know. And also the idea of space, being in space, how the sound travels from one object to another, from a surface like a wall, reflecting back, how long it takes for the sound to out of my mouth back, reflecting back. Then we have amplitude, which is the extent of the air compressing and rarefies. And then we have the different wave forms, one being from the waveform you get in the guitar string, which is called a transverse wave, and the wave that is in the air that moves parallel with propagation, longitudinal wave. And then also how amplitude is measured in decibels, and the different types: dB SPL, which is decibels of sound pressure levels, and then dB FS, which is full scale, which you get in the computer. One being from the most softest note to the most loudest note, which is dB SPL, and from the most softest note to the negative, which is FS, full scale, which you get in the computer. And this is an overall recap. The mostly positive dB you get outside in the air, negative dB you get in the computer. So I hope this helped you. Thank you very much for watching, and I hope that I gave you some good information. Thank you. Take care.